Hi. We now have another workshop right now. We have, I believe, Matthew from Streamr in the call, who's going to be giving us a workshop on extending your video app using Streamr. Hi, Matthew. How are you doing today?
I'm good, Jenny. How are you?
Yeah, really well, thank you. Really excited for this session. So without further ado, I'll pass things over to you to get going with the workshop.
Let's start off with maybe a bit of an introduction to what Streamr is. Maybe firstly about myself. I'm head of ecosystem at Streamr. I've been with the project for almost 5 years now, and we're old for crypto projects in the space. And it's been a long roadmap that we've been going on, but it's quite a serious one. We want to contribute in a way of creating this decentralized data infrastructure and kind of extend the internet with this new capability of being able to kind of stream data in these many-to-many patterns. And so if you're familiar with PubSub, the Streamr Network is kind of like a PubSub network where we have data publishers that push data into the network, and you have data subscribers that consume that data. Otherwise, you can call them a few different things: consumers, subscribers, it's all the same. And a nice kind of analogy to think about this is that we're a bit like BitTorrent, but for real-time data streams instead of static files. And I will get into kind of the meat of that very shortly. So a bit more definition to what this is. The network itself is off-chain, so a lot of the time folks come in, they see crypto project and they think blockchains. This is not true for Streamr. We leverage blockchains, we have touch points there, but the data is flowing off-chain, and this is how we can really get massive scale and speed, but we can also really leverage a lot of what's in the crypto ecosystem. So what is on-chain, specifically the Polygon blockchain? We have our stream registry, which contains all the streams and who can read and write to those streams, i.e. the access control. And we use the Ethereum-based cryptography and identity. So data publishers, they kind of publish with their public key. They sign every single payload or message into the network with the key that only they know. And so you get a lot of interesting properties from kind of having being off-chain, but still having some exposure to the blockchains. So let's jump into an example here. So this is the Streamr.network website. It's just like any other website, except when you scroll down a little bit, you hit this data feed. And what's interesting about this data feed is that it's not coming from the central server. It's actually coming from other visitors that are also on the Streamr.network website at the same time as you. So what's happening is that you are forming a mesh network with all the visitors that are also on the website at the same time as you, and you help propagating that data feed around to everybody else that's interested in that data. And so this is what it actually looks like. It's, as I mentioned, it's a bit of a mesh network, or what we call a network topology, where folks create 4 connections, 4 random connections to others in the topology, and they're able to kind of push and pull data amongst themselves. So in the BitTorrent analogy, this is like your kind of seeders and peers sort of a setup here. So one of these nodes is the original publisher of the data, and that is just a traditional script on some server. But the more and more subscribers that join this topology, the more likely it is that you will consume that data from one of these peers. And this is the Network Explorer, and you can check it out on your own as well. And in the top left, I've plugged in the Stream ID, and that's how you find stream topologies. It's all open. So what properties do we have here? So it's really fast, i.e. real time. So messages of just about any topology size get delivered within 1/3 of a second. And it's scalable as well. So we've done a lot of testing around network topology sizes, and we can really stand behind being both fast and scalable. Permissionless and censorship resistant. For the crypto natives, this is kind of course, we value decentralization, and you get these kind of properties out of the box. Tamper-proof, so like I mentioned, the publisher is always signing every single data point, so you have absolute confidence that the data came from that specific data publisher. So if you imagine a Twitter built on Streamr, you wouldn't have to second guess, if someone's hacked Twitter and someone's taken over, the president's account and tweeted all these interesting things. You can have cryptographic proof that the publisher is the publisher for every single message. We offer end-to-end encryption, and that's optional. So you can have public streams or private streams. It's green, so instead of these always-on data centers, you can kind of leverage the the latent bandwidth of always-on devices, and it's free to use. The little asterisk is there just because it just costs a little bit of gas to create the stream, 1 or 2 cents. And we're getting around to sponsoring this, so it will be totally free very soon, but it's, essentially free. So let's talk about how we can kind of push data into the network. So, you're in a hackathon and you want to use this thing. So there's basically 2 main ways, but I'll kind of speak in the abstract first, that applications publish and subscribe to streams. Streams are like channels on the Streamr network, and the nodes are the access points to the Streamr network as well. And I'll get into that. Might be a little bit confusing now, but in the next slide will be very clear. So to connect to your application to streams, you interface it with a Streamr node. And so there's 2 ways of doing this: the light node or the broker node approach. So the light node is essentially just a JavaScript client that you can plug into anything that's running JavaScript. So Chrome extension, website, web app, React Native app, Node.js script. The node, so you kind of npm install Streamr-client. And when you do this, when the app runs, it's actually running a node inside the application. So kind of job done, and then we have all the methods and all the convenience functions there to kind of interface with the Streamr network very easily. And the second option is the broker node approach. So let's say you're not building in JavaScript, then you can spin up a broker node in some environment that is capable of running Node.js, maybe on the cloud, maybe on your computer. And you basically open up an interface, either HTTP, WebSockets, or MQTT. And so whatever language application that you're building, I can assure you that it has either a HTTP, WebSocket, or MQTT library. And all you need to do is kind of push data to that broker node, and the broker node will handle the rest, and it's able to kind of push into the network. So again, applications that are JavaScript, super easy. You just initialize the client. Here is the usage of the private key here. You can also create burner accounts as you please. That's no problem. And it's an example here of streamer.publish. mydomain.eth/test is the stream ID, and then hello world is the data message payload. So publish or subscribe there. And the broker node looks a little bit like this, where you connect to the broker node and do the exact same thing of publishing and subscribing on whichever interface you choose. And as promised, the Streamr client is on NPM, easy to find, well documented, and can plug into your app. And if you also visit the Git of Streamr, there is an examples repo to kind of get you more acquainted with the protocol. And if that wasn't good enough, we also have a user interface to help you guys create streams. So you don't even have to touch code if you don't want to, for this part at least. So at the top right there, you can click Create Stream. This is the streamr.network/core. And then you basically just log in with your MetaMask, and it will scoop up your Ethereum public key from the accounts of MetaMask, and then you just add in a path name and click Create Stream. That's a transaction on Polygon. So this is where the gas comes in. So you'll need a tiny bit of Matic to get started. And once the stream is created, you can kind of start using it in the Streamr client, or you can do a few things here in the interface as well. So in the share settings, sometimes a few people have had a little trouble finding this, but in the stream settings is the access control in the like an interface option for the access control. So that can be quite handy. Okay, so let's talk about some use cases for using this thing, because it is quite novel, and I think perhaps maybe the hackathon folks have a bit of experience with the other messaging protocols. So we kind of characterize ourselves as a data protocol, but you know, what's the difference between a data point and a message, right? It's all the same. So whether you see us as a messaging protocol or a data protocol, up to you. But in terms of how we kind of present ourselves, we say that we have two main use cases here: decentralized communication and data sharing and monetization. So on the communication front, this is just generalized messaging, can be between Ethereum wallets, can be machines, IoT, whatever you want, other nodes and other networks. Anything is fair game. So a little internal project that we've been working on that you can check out is a wallet chat, a group wallet chat. That we've built, and what's really fun about this is that there's no servers. It's you can really chat with your friends and create these kind of mesh networks behind the scenes, and not really need to interact with, you know, Google or whoever. Can be end-to-end encrypted. You can create these token gated experiences because our access control is on the Polygon network. So you can have chat rooms that require a certain NFT or a certain amount of an ERC20. So I recommend you check this out. It's open source, and there's a demo as well. So it's yeah, quite cool. Then there is decentralized live metrics gathering. So this is an example of a bit more of a data transport use case. I think this will be quite interesting in terms of what could be achieved with, say, Livepeer plus Streamr. So this is an example of how we collect metrics on our own network, and basically you can get this zero-party data coming from the nodes themselves and push towards an aggregator script, and then have really strong guarantees about the data that you're collecting about a decentralized network. And you can use centralized technologies to monitor these networks, but it kind of spoils the fun. So if you use Streamr to gather metrics on a decentralized network, you can keep the open principles of the whole system intact. Then there's data sharing and monetization. So I think in terms of this hackathon, sharing open data is would be quite interesting, I think, to see what sort of data that can be shared for these particular video streams, and actually building on that data as well. So creating applications based on some form of data is also quite interesting. So we have a marketplace that can, you can create your project here as well and get a bit more visibility. And each one of these projects is a collection of streams on Streamr, and you can create pay to access sort of, I guess, like it's kind of like a product, and you can choose any sort of crypto to be a pay to access sort of experience for your users. So to the hackathon ideas, this is the last slide as well. So my colleague Nico couldn't make it for this one, so maybe it's a little short, but it leaves some time for questions if there is any. But I can go into a bit more detail here on these. So perhaps my favorite, I added a star because I like it so much, is live video health metrics over Streamr. So if you can imagine a Livepeer app where you can get that real-time data feed of say the latency of your of the end users, if they are receiving the video stream in good quality, how engaged they are, the kind of, perhaps is there some sort of transcoder redundancy, or I guess you guys will know the Livepeer environment a bit better than me, but I'm sure there are metrics from the Livepeer system that will be really important to kind of provide a good video experience for the end user. So I think this one is probably like the match made in heaven, but yeah, I leave it to you guys. The other big one is social video streams. So I think that you guys are probably quite aware of the other protocols that are also doing some sort of social features. I think Streamr is also very good at this, and it's been very popular at previous hackathons to integrate live reactions into some sort of in some sort of real-time experience. You can also have voting, because all the messages are signed with the user's key, so you can get strong off-chain conviction voting for whatever video stream that maybe it's like a well, yeah, there used to be these novels where you got to choose which direction you go. Maybe they're still going, but perhaps a video stream can kind of be guided by the viewers. Perhaps they can kind of steer the content in some way using voting, and I think that would be a really fun social application and good use of the technologies. And of course, there's chat. Chat is fantastic, and yeah, I think like any sort of token gated experience, or just any sort of chat experience, is always welcome. There's open data sharing. So I touched on this earlier, but I think it's just really fantastic to be able to share these sorts of kind of usage metrics on these Web3 protocols. So it's very early days for the whole Web3 ecosystem, and there's a lot of kind of hot air floating around. But what's better than sharing real zero-party data. Zero-party means coming from, directly from the party, from the users themselves, on how they're using these technologies. And so lots of different folks are interested about, are these protocols actually being used? And I think it's great that protocols can kind of point to Web3 native solutions that give strong guarantees about the usage of their own protocols. So how many viewers, how are they engaged? Did they did they see the ad that you posted in the video? I think these are all really interesting, valid use cases for video streams of all sorts. We can have pay-to-access video streaming. So like I showed you in the marketplace, where I mentioned that you can buy time-based subscriptions using any crypto for any collection, well, any product which is a collection of data streams. Perhaps you can create a pay-to-access video streaming service using maybe Livepeer tokens or some sort of crypto to maybe for discoverability, or maybe to access the raw byte feed. I leave that to you. And the last one is a tough one, but it's also, probably the the most awesome. It's live video distributed over the Streamr Network. So at the moment, the Streamr Network is only capable of putting of JSON data points. So this one will be tricky. And in maybe about 6 months or so, we will be transitioning to raw binary throughput. So to accomplish this one, you need to do like a little bit more legwork to encode the raw data packets into JSON and then decode them at the subscriber side. But it would be pretty amazing to be able to see the Streamr Network be the distribution arm of the Livepeer transcoding network. So if you can pull this off, wow, you guys deserve a prize. It's tricky to do at the moment, but we really kind of see this as an amazing use case for Streamr. So yeah, that's the I guess the scope or the breadth of the use cases that I can see would be great for this hackathon, but of course open to everything. And yeah, I think I'll leave that there and open to questions.
Thank you very much, Matthew. That was really interesting. Really, especially like the hack ideas to give people some inspiration. Yeah, so as Matthew said, the floor is open to questions. Write them in the chat, or you can ask them over the microphone as well.
Any sort of boilerplate code, I'm happy to share as well. It would also be fun to do like a Lens protocol / Streamr integration, get some group DMs happening over Lens profiles. That would be fun. And yeah, just sort of any sort of integration that touches a handful of Web3 protocols is kind of amazing to see. Like we've also had integrations with like Arweave that was previously on, and these sorts of protocols. So the great thing in Web3 is that all of our protocols are so composable, so you can really kind of pick the chocolates and combine them all together. So yeah, really recommend you guys dive into our docs and give it a go.
Awesome. And also, if you do have questions later on, we'll be very happy to help get those answered on the Discord as well. If not, I think we will wrap things up there slightly early. Thank you, Matthew, for coming in. It was super interesting. And we hope to see lots of great builds coming in over the next few weeks. Yeah, so I just want to say thank you. And do you have any closing comments?
Oh no, thanks everyone for listening, and yeah, again, we're here to help. We want you to succeed. So don't be shy. Please be chatty if you run into any sort of issues or just want to chat. Yeah, we really appreciate, and we really want to kind of support our grassroots developers as much as we can. So you're our heroes, and yeah, we want to give you everything that you need to do your job. So yeah, happy hacking.
Awesome. Thank you. Thanks for coming in, Matthew. We'll wrap things up there. Have a great rest of your day. And for everyone else, we will have some more workshops tomorrow. We have one with Polygon and we have one with Ceramic. So we will see you tomorrow for those. Yeah, have a great evening and rest of your day, everyone. Goodbye.